go ahead and get started here. How do we know when a fire emergency occurs in a building? If you're not in the area where the fire actually breaks out, it's very possible, we may not even know that there's a fire happening somewhere. And so that's really the purpose or meaning behind our discussion today. Without alarm notification, the occupants of the building may be unaware that there is a fire emergency until it is too late. So our presentation today is designed and intended to introduce us, come on computer here, it's going to introduce us to the requirements found in NFPA 72 for notification appliances. This is not going to be a complete discussion of all of the requirements, but we're going to try to cover some of the basics as we go through it. So again, any questions, type them in anytime, and we'll get to those at the end of the presentation. Our presentation today will focus on public mode requirements. Public mode is notification that is intended to notify everyone in the building, all right? And that's commonly what we would see in most buildings. There is a mode called private operating mode. Private operating mode is going to be used in a special set of circumstances, maybe a hospital might be an example, or a prison, where only certain select people are notified of the fire emergency. They then are able to decide how to react to the emergency. In a hospital, some people may need help. They may be in a bed, they're unable to get up and move. Obviously, in a prison, people are confined. So private operating mode is something special. Public operating mode is what we see for the majority of our systems installed in commercial buildings. That's what we're going to focus on today. Now, thinking about notification appliances, even more basic than that, really, how do we know when we need to have a fire alarm system in a building? Well, in the United States, it is usually a building that will require that. In this case, maybe the IBC, the International Building Code. Much of the United States comes under the International Building Code. In other places or applications, it might be NFPA 101, which is the Life Safety Code. These codes will tell us when a fire alarm system needs to be installed, depending on the type of building, the way the building is to be used, the occupancy type of the building. Once we know whether a fire alarm system needs to be provided or not, now NFPA 72 will tell us how this system must be installed and how it must perform. For example, here, this is taken from Annex A in NFPA 72. And by the way, I should mention that all of the quotes that we'll see today are taken from the 2019 edition of NFPA 72. But here it tells us that Chapter 19 establishes the means and the methods and the performance requirements, but it does not require the installation of notification appliances. It's the building code that tells us when they're needed. NFPA 72 tells us how they must be installed and how they must perform. Okay. A couple of the requirements. One is listing. Chapter 18 is the chapter that deals with notification appliances primarily. And one of the big requirements is here, all notification appliances installed in conformity with Chapter 18 shall be listed for the purpose for which they are used. Now, normally that's UL listing. That's what most companies do. That's what most people look for. There are other listing agencies, but UL is really the big one all around the world. And so the notification appliances must be listed for the purpose. If they are going to be used in a special environment, maybe outdoors or in a high temperature or a dusty condition or something like that, they must be listed for that special application as well. Okay, so the listings are very important when it comes to selecting the notification appliances that we want to use for our project. Chapter 18.4.1 tells us that in order to be sure that the signals are clearly heard, we're talking about bells or horns or something like that. In order to be sure that they're clearly heard, they must have a sound level at least 15 decibels above the average ambient sound level, or 5 decibels above the maximum sound level, having a duration of at least 60 seconds. And that makes sense. We need for the sound to be louder than what's going on in the room around us. If it's not, we don't know that people are going to hear it. Okay, so for public mode, 15 dB above ambient is typically what we're going to be trying to achieve. Now, there's also a special signal pattern that is used. It is the 3-pulse temporal pattern, commonly called temporal 3. And I'm sure we've all heard this pattern. This pattern is what is required by NFPA. And this is the pattern that is intended to notify people that there's a fire emergency and that they either need to leave the building or they need to relocate to another part of the building. And if you haven't heard the temporal 3 pattern, I will play it for you here. It's a definite 3-pulse pattern, half second on, half second off, and it follows this, this sort of format as is shown here. This is actually required as a part of NFPA 72. So for fire alarm sounds, they should follow this temporal 3-pulse pattern. Now, if the alarm signal must be 15 decibels above the ambient sound level in a building, how can we know how many appliances to use? You know, when we're designing our system, we're trying to create the parts list. You think, well, how many horns do I need? How many bells do I need? There is a way to sort of figure it out. We'll talk about that here. It's based on information found in Annex A, Table A.18.4.4. And what this table does is the technical committee gave us the average ambient sound level in different types of occupancy. So if you have a business occupancy, an office, typically it's going to be about 54 dB. That's the average sound level. If you have a mercantile, a store or something like that, 40 dB. If you have a place of assembly or residential occupancies or storage, they've given us all of these different applications and the average typical sound level at any given time. All right, so let's think about how we could use this table in the design of a system. Let's consider a business occupancy in office, all right? And we're going to use the Hochiki HEH24 wall mount red low profile horn that's pictured here. And we need to know how loud is this appliance. So if we look at the data sheet, if we use the continuous 2400 hertz setting on high, the data sheet tells us that it will produce at least 81 decibels at 10 feet, all right? So I know how much sound I can get out of this appliance using this particular setting. Now, how do I know how to space the horns? Well, if we look back at the table, it tells us that a business occupancy is typically 54 dB, and we know that we need to be 15 dB above 54. So if we add 15 and 54, it tells us that we need to have at least 69 decibels throughout the protected space, okay? So to determine our spacing, we're going to use something that is called the inverse square law. This law partially says that if we double the distance from the sound source, we will lose 6 dB. So every time we double our distance away from that horn, we're going to lose 6 dB. Okay, so let's take a look at it here. We know, according to the data sheet, that 10 feet away, it's going to be at least 81 decibels. If we double 10 feet to 20 feet, we're going to lose 6 dB. So 81 minus 6, we're down to 75. If we double 20 feet to 40 feet, we're going to lose another 6 dB. 75 minus 6, that gets us to 69, which is exactly what we determined through the use of the table that we needed to have. That is the minimum sound pressure level that we need to have throughout the protected space based on that table in Annex A. So what about our spacing? Well, our spacing is going to be 140 feet between appliances, because from here, 70 feet, let me go back to the previous slide, 40 feet plus 20 plus 10 is 70 feet. So I've got 70 here in one direction, and then I've got 70 feet in another direction, 140-foot spacing between appliances, okay? And that's how we can get an idea of how many notification appliances, audible appliances, that we're going to need for our application. Now, if there are walls or doors or other things in the room, obviously that's going to have an effect on the actual volume of the appliances and the volume in the room. So to be sure, we always want to take measurements to confirm the actual sound level of the office under normal circumstances. But at least this can give us an idea of how many audible appliances we would need when we're in the initial design phase. Now, what about the installation of these appliances? How high should they be mounted on the wall? Well, NFPA 72 tells us about that as well. It tells us that the top of the appliance, if the ceiling heights allow, if the ceiling's high enough, the top should be not less than 90 inches or 2.29 meters, but the top should be not less than 6 inches or 150 millimeters from the ceiling. So we're going to have this range here, somewhere more than 90 inches from the floor, but more than 6 inches down from the ceiling. And that's where we will want the top of the appliance to be located. Now, if we have horn strobes, combination audible visual appliance, then we're going to follow the requirements for visual appliances instead. So this is only going to apply for horns or bells or just audible type appliances. Okay. If the notification is for a sleeping area, maybe in a hotel room or residential room, things like that, there are going to be additional requirements for us. Probably everyone knows about the 520 hertz requirement for sleeping areas. Briefly, if you don't, NFPA and UL, they did research about what is the best frequency to wake people who are asleep or maybe who are impaired in some way. And they did a lot of research, and they found out that 520 hertz is ideal for waking people who are asleep. 520 hertz is a lower frequency than what your typical horns provide. So for sleeping areas, 520 hertz is automatic. But there's another requirement too. You remember how we said the sound level has to be 15 dB above the average ambient sound level? That's true, but for sleeping areas, it needs to be at least 75 dBA. 15 dB above average or 75, whichever is greater, and measured at the pillow level. So we're going to take our measurement where the pillow is at that level from the floor. We're going to be sure that we have at least 75 dB for this application for sleeping areas. Now there's also carbon monoxide alarms too. This is another serious matter. Carbon monoxide poisoning is really a big problem. And the notification for a CO alarm is covered in NFPA 72. It needs to be a distinctive signal pattern, and it has to be different from the fire signal. We heard the temporal 3 pattern a few minutes ago. The CO alarm is called commonly called a temporal 4 pattern. Rather than 3 pulses, 500 milliseconds each, the temporal 4 uses 4 pulses, and they're 100 milliseconds each. I'll play the temporal 4 code for you, and you can hear how that. So you hear the 4 rapid pulses and then a longer period of time in between. For CO alarms, the residents need to understand that that's what this tone, this signal indicates. And they need to get out of the room and get to a place where there's fresh air. CO poisoning obviously is a problem because carbon monoxide can't be seen, you can't smell it, it has no taste or anything like that. But it will overcome a person so much if the concentration is high enough. It will overcome a person until they become unconscious and possibly even die. And Hochiki has the ACD, smoke, heat, and CO detector that will provide CO detection for CO poisoning. And it works along with the low frequency sounder base that will provide this special notification for CO alarms, in addition to the temporal 3 for fire and things like that. So CO alarm, CO poisoning is another matter, an important one, and it is one that NFPA 72 also talks about. So we talked about audible notification. Now what about visible notification? Strobes. We use strobes very often throughout buildings. For mounting them, they have to be mounted such that the entire lens of the strobe is not less than 80 inches or not greater than 96 inches above the finished floor. So the entire lens is going to be not less than 80 or 2.03 meters, I'm sorry, but not greater than 96 inches, which is 2.44 meters. So there's going to be this little window of space here, and we need to be sure that the entire lens of the appliance is located within that little space on the wall. The spacing is a little more straightforward for strobes. Rather than having to use the inverse square law and work out the sound level of the room, we're given tables that we're able to locate our strobes based on the size of the room. We'll look at that in a moment. And another matter here has to do with synchronization. When the strobes are flashing, if we have more than one strobe in the same field of view, all right, so if I can, see 2 or 3 of them or 4 flashing at the same time, those strobes have to flash at the same moment. They can't be flashing at different times. There is a possibility that some could have a reaction to that, and actually could cause them to go into a seizure. Some people have photosensitive epilepsy, and so they must flash in synchronization. The audible sound has to be synchronized too. We heard the temporal 3 pattern. Bam, 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 bam. If they're multiple horns that are going bop, 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 bop. You won't be able to recognize that pattern, that distinctive temporal pattern that tells people this is a fire and we need to leave. Now, the synchronization is taken care of by the horn strobe manufacturers. There are synchronization protocols that provide a proper pulse to all of the devices so that they will all work together in synchronous operation. And we have that included in the Latitude panel, in the FireNet Plus panel. If you are doing notification appliances with other systems that don't have synchronization available, there are special synchronization modules that will provide that operation. So synchronization is also a requirement, and it is one that is very important. Now, when we look at the spacing of strobes in a room, on a wall mount type of application, what we need to do is determine the maximum size of the room, okay? For example, here, 6.1 meters squared. It tells us we need one appliance, and the appliance must be set at 15 candela. If we had a larger room, say this one, that's 15.2 meters squared, 50 by 50 feet, we could have one 94 candela appliance, or we could have 4 appliances, one on each wall, each appliance with a candela rating of 30. Okay, that would also comply with the requirements. Now, when you get up here to some of these big rooms, like this 39.6 square meter room, and you need a 635 candela strobe, obviously, I don't think there exists a 635 candela strobe. So we're going to be breaking this down into smaller rooms, which is permitted to be able to cover it in that way. And here's a sort of a visual diagram that is also taken from the code. If I have a room that is 6.1 meters squared, 20 feet by 20 feet, one visual appliance in the center of any of the 4 walls, directed into the room, and I'm fine. Okay, but it has to be in the center of the room. The location is important. If we take a look here, again, let's consider our 15.2 square meter room. And it says I can protect that room with 4 30 candela strobes, one on each wall. I can't do it like this. This would provide a coverage, a square sort of coverage, as would all the others, but it's really going to leave the corners of the rooms without proper illumination. Rather than do this, what we do is we consider that the room is divided into 4 pieces, and then we protect each section by putting the strobe in the middle of that part of the room. So this box here represents the coverage of this strobe, and it's installed in the center of the wall of this imaginary smaller room. We do the same thing here and here and here. This would be the proper coverage. This sort of coverage would not comply with the requirements. We also might have a room that is an unusual shape. For example, here, this room is 12.2 meters long. On this end, it's 3.1 meters. On this side, it's 6.7 meters. Well, how am I going to view this room when it comes time to protect it? You know, I can't do 20 feet, 6.1 meters, I think it is, because that's too small. If I do 30 feet, as is pictured here, 9.1 meters, I cover this distance fine. But the 9.1 meters in this direction doesn't cover me here. I need to look at the longest length of this room. In this case, it's 40 feet or 12.2 meters. And I need to design and choose an appliance that would cover a 12.2 meter square room. That's going to be the proper way to choose the appliance for this application. We can use ceiling mount strobes as well, and there's a table for that, and it follows a similar sort of scheme. We look at the area of the room, square feet, square meters. We look at the mounting height of the strobe, 3 meters, 6.1 meters, or 9.1 meters above the floor. And then we can choose, or obtain the correct candela rating to be sure that we properly cover that area. So if I have this room, that's 21.3 square meters, and I'm going to mount my strobe 9.1 meters above the floor, my strobe needs to be at least 185 candela to cover that room properly. If my ceiling height is greater than 9.1 meters, I'm going to have to suspend the strobe down so that the strobe does not exceed 9.1 meters from the floor. All right. Okay. So there are other types of notification that we didn't talk about. Textual notification is one, which is speakers. There are graphical notification appliances, which is signs. There are tactile notification appliances. Maybe you've run into those. They are pillow vibrating devices or bed vibrating devices. When the fire alarm goes off, it vibrates the bed, which will help to awaken people who are hearing impaired and notify them of the emergency. So all of these are considered in Chapter 18 of NFPA 72. For the requirements on those, you can check that standard. You can always reach out to us as well, and we'll be very pleased to assist you, support you with questions about the code and things like that. There's one more topic we should discuss, and that's voltage drop calculations. Notification appliances are normally connected to the panel using wire. We've got our panel, we've got wire, goes to one notification appliance, and then a second and a third, all the way out until the end, okay? And that wire, because wire has a resistance to current flow, some of the voltage from the panel is going to be lost, or it's going to be dropped along the length of that wire. And we need to account for that, because if I start out at the panel with 20 volts or 22 volts or something, and I drop that voltage all the way out the wire until I get to my last appliance, maybe I don't have enough power to operate that last appliance or last group of appliances. So voltage drop is very important. It is required to be a part of the plans when we design our system. Voltage drop is a requirement. It's usually calculated using this formula. The total voltage drop equals the total current draw of all of my appliances multiplied by the total wire resistance. Now, most manufacturers have calculators that can kind of do this for you, and Hochiki is no exception. We have voltage drop calculators. At the end of the presentation, I'm going to give you a link with some calculators in that file that you can use. But just for us to kind of understand how it works and why it could be a problem, let's take a look at an example. Let's suppose we're going to use the Hochiki HEC 24 wall mount horn strobe appliance, okay? And we're going to use the 75 candela setting, and we're going to use the temporal 3 tone. So we can look on the data sheet and we can figure out what the current draw for the appliance will be. For the horn part, it's going to require 28 milliamps, okay? So 28 milliamps for the horn. Now for the strobe, we've got two ratings here. We've got 80 milliamps. We've got 116 milliamps. The 80 milliamps is at 24 volts. 116 milliamps is called the UL max. When UL tests these appliances, they test them over a wide range of voltage, and they measure the current and they identify what is the worst possible current draw that this appliance will require. And that is what they give us as the UL maximum current. I would recommend that you always use the UL max when you are doing your voltage drop calculations and your battery calculations as well. And the reason why is this. When the panel goes into alarm, it's possible that the electricity may have been turned off and we might be running only on batteries. And those batteries could be less than 24 volts. It's also possible that this appliance could be at the end of a long piece of wire, and so some of the voltage may have dropped as well, okay? So let's imagine the panel has 22 volts instead of 24. As the voltage drops, the current requirement of the appliance is going to go up. So if we calculate it using 80 milliamps, we're thinking that there's going to be 24 volts present when perhaps there will not be. So in order to calculate the worst case scenario, use the UL max, and that way we should be covered under any type of situation. So 116 milliamps, 28 milliamps, that gives us a total worst case current draw of 144 milliamps for one appliance. What is the minimum voltage that this appliance can operate at? The data sheet tells us 16 to 33 volts is the operating range. So this appliance will operate correctly down to 16 volts. Now, what about the wire? That's the last little part of this. What are the specifications of the wire? If you can get the manufacturer's data sheet, you can find the information there. If not, you can refer to information, such as this table, which comes from the National Electric Code. And let's imagine that we're going to use 14 gauge or approximately 2 millimeters squared cable. It has a resistance of 3.07 ohms for every 1,000 feet. Okay, 3.07 ohms for every 1,000 feet of wire. Well, our circuit's going to be 400 feet in one direction. That's 400 out and 400 back for a total of 800 feet of wire. 3.07 ohms per 1,000 feet, but I only need 8% of that, or 80%, so 3.07 times 0.8. My wire will have 2.456 ohms, 800 feet of wire. That's what I'm going to have. So here's my formula. I know that the wire is 2.456 ohms. I have 8 appliances I'm going to use. So if I multiply 144 milliamps times 8, the total current draw will be 1.152 amps. Here's my wire resistance. Here's my current draw. The voltage drop is going to be 2.833. That's how much voltage I'm going to lose due to the resistance of that wire. Now, again, as we kind of discussed, we're not going to consider that we're starting with 24 volts. NFPA 72 says equipment needs to operate at 85% of its voltage. So 85% of 24 volts is 20.4. So that's where we start, okay? The wire will drop 2.833 volts, 20.4 volts at the panel minus our voltage drop, 2.833. We will have 17.5 volts approximately at the last notification appliances. Now, the specification told us that 16 volts is the minimum, so we're okay, okay? We have 17.5 volts. It'll work down to 16 volts, no problem. But what if we wanted to use 13 of the same appliance for our circuit? Well, 13 times 144 milliamps is 1.872. 1.872 amps multiplied by our wire, our 800 feet of wire. Voltage drop is 4.6 volts. 20.4 minus 4.6, I only have 15.8 volts. Remember, the minimum voltage is 16 volts. So this design is not approved. It would not work. We would have to either adjust the number of appliances, possibly the length of the wire, or the size of the wire. If we go to a larger wire, it will have lower resistance. So these things kind of work together to help us figure out how many appliances we can have and how far away from the panel they can be. Now let's go back to the 8. What if we wanted to use 8 of these horn strobes, but instead of 14 gauge, we wanted to use 18 gauge wire, a smaller wire? Well, we know what the current draw is of the appliances. We already worked that out, 1.152 amps. But what about the wire? 1,000 feet, 18 gauge is 7.77 ohms. 800 feet of that, 6.216 ohms. If I do the math, I'm going to drop 7.16, 20.4 minus 7.16. It's not going to work. I'm going to be far below 16. And I can pretty well imagine that those notification appliances are not going to work. So voltage drop is important. Again, we have calculators for that, but it's good to know how it works and how the different parts work together, so that if you have a circuit that is not working for some reason, you know what you can change to possibly correct it and make it better. So that really sort of brings us to the end. As I said at the start, this is really an overview, a sort of an introduction to the requirements for notification appliances under NFPA requirements. It has not been a complete discussion. But if you have questions, if you're using NFPA, or if that is the code that you're required to follow, take a look at the document. Also, if you have any local requirements for fire alarm systems, be sure that you're aware of those too. And you can read the NFPA standards, all of them, online at nfpa.org. You have to sign up for an account, but you sign up and there's no charge. You can view all of the documents, new and old. They're all there completely available for you to see. And also, please feel free to use us as a resource as well. If you have a question about NFPA requirements or UL or anything like that, please reach out to us, and we will do our best to support you and help you with that as well. We're involved with these quite regularly, and we'd be happy to help you with anything that comes up. Okay. So always remember that we're designing and installing and maintaining life safety systems. These systems, when they're designed and installed and maintained properly, they save lives. And that is an important and valuable work. The work that you do may save a life. And so please remember that the work that you do day in and day out in this industry is valuable and it's important. And we thank you very much for your attention and for your support of our company and our products. Thank you for the work that you do. And please let us know what we can do to help you as well. We are preparing for additional webinars on various topics. Probably we'll have another one at the start of the year. So keep an eye out for that. And I hope that we'll be able to see you again on another webinar coming up soon. So thank you all again very much. And I hope that you have a great day and a great weekend. Take care.